Hey guys, so today we are going to do the last lesson from chapter 3, 3.5, and it's on arithmetic sequences. Okay, and you're going to understand why this is part of chapter 3 and why we connect it to chapter 4 as we get a little bit more into chapter 4. So remember I was trying to tell you what this is called when we take a vocab word and we stick it in the center and then we break it into 4 parts. I could not for the life of me remember it, but I finally did. It's called a Freyr model, F-R-A-Y-E-R, most likely named after some guy named Freyr. And it just helps us kind of not just give a, single definition, but to break it into components. So on the upper left, remember this is going to be the definition. And the upper right is going to be characteristics. The lower left is going to be examples. And the lower right is going to be non-examples. Alright, so let's start with the definition. And the definition is a sequence is an ordered list of numbers So basically what that means is that the numbers are in a particular order. There's some reason why they are what they are. Now, that goes with the word sequence, obviously. Now, arithmetic means it uses adding or subtracting a common / repeated, so it's the same thing over and over again, value to get to the next number. Okay, so we're either going to be adding the same number over and over and over again to get to the next term in the sequence. Okay, let's talk about some characteristics. So each term, or each value, I just gave away the word, is called a term. We've seen that word before. Each part of a polynomial is a term. Okay, same idea. So we have some kind of key players when it comes to the arithmetic sequence. So first is the first term. So it's the first term in the sequence, and he's known as A sub 1. And then we have any term in the sequence. And since we don't know exactly who he is, we just use an n to represent some number in the sequence. And then, remember how it said that there was this common, I wrote repeatedly, it's supposed to be repeated, let me fix that. Repeated value, there we go. So then that common difference between the terms give some space to that. So what is that pattern? He's known as lowercase d. Okay. All right, so what are some examples? So I'm going to give you some real easy examples. 1, 2, 3, 4, 5, and then ... means and it continues. So we're going to look for what goes between. To get from 1 to 2, I add 1. To get from 2 to 3, I add 1. To get from 3 to 4, I add 1. 4 to 5, I add 1. So that's your common difference, is 1. That's your D, okay? Let's do another one. Let's see. Again, pretty recognizable. Oops. 2, 4, 6, 8, 10, and so on. So in this one, let's see. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. 8 plus 2 is 10, and so on. So the common difference in this particular one is a 2. All right. Let's give you a couple of examples of patterns that aren't arithmetic. 1, 1, 2, 3, 5, 8, and so on. Now, this is a pattern, and it's predictable how to get to the next one, and so on and so forth, but it's not arithmetic. So let me prove that out to you. So let's see. Let's go to this color. I would add nothing to 1 to get to 1. I would add 1 to 1 to get to 2. I'd add 1 to 2 to get to 3. I'd add 2 to 3 to get to 5. I'd add 3 to get to, from 5 to get to 8. So what you're seeing is it's not a common difference. It's not a common difference. So there is no D, okay? So that is actually, there is a pattern though. This is called the Fibonacci sequence, and by a guy named Fibonacci recognized this. This pattern actually exists in nature, many, many kinds of things. So what you do is you add the 2 preceding numbers to get to the next number. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. The problem with this guy, it's hard to say, well, what's the 152nd term? That's going to be hard to get to, okay? All right, here's another example of a pattern, but it's not arithmetic. 2, 4, 8, 16, 32, and so on. So we're looking for a D. 2 plus 2 is 4. 4 plus 4 is 8. 8 plus 8 is 16. 16 plus 16 is 32. So it's definitely not arithmetic, but look this way. How about 2 times 2 is 4? 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So this is not arithmetic because it uses multiplication. This is actually called a geometric sequence. So we're not talking about geometric sequences, we're talking about arithmetic. And the reason why we're talking about arithmetic is because, again, there is a connection between rate of change, a constant rate of change, and linear equations. All right, so let's write down a little statement over here. In an arithmetic sequence, the common difference, D, is, here we go, always constant. So we talked about a constant rate of change would give you a line if you graphed it. And we said that's this, we're going to change its name now from constant rate of change because that's a lot of words. We're just going to call it slope. Okay? Now, we're going to talk about a formula you're going to use to help you predict what number would be the 521st term. Okay, you're not going to sit there and count out 521 terms. You do that, you won't get full credit for the question because it's about practicing the formula. Now this should still fit on the same page, so I'm just going to move to here to have plenty of room. So arithmetic sequence formula. Oh, that was a weird way of spelling formula. Let's try that again. Okay, so the arithmetic sequence is an equation to calculate a sub n, any specific number, in the sequence if a sub 1, the first term in the sequence, and D, which is, and let's get D in there, the common difference are given. Now that's not the only thing they're going to ask you. Hey, you know, what's the 521st term in the sequence? They're going to ask you other things. So here's a couple other things they may ask you to figure out. They may ask you to find the first term in the sequence, a sub 1, but that means a sub n and d, the common difference must be given to you. By the way, if you hear a weird noise in the background, that's the fire going. It's a little cold in my room. Second thing is you might actually be asked to figure out n, which is how many terms, or you know, where is this term located, or the common difference, the d, if given the rest of the information. So in other words, you can't have both of those missing. But let's say you're given a sub n, a sub 1, and n, then you can figure out d. If you're given a sub 1, a sub n, and d, then you can figure out n. Okay? Now, they're not going to always tell you what the n number is. They're just going to give, for a sub n, they're just going to give you a number. Okay? Your job is to figure out where that number is in the line of numbers. Okay? So we're going to go through the formula. I'm going to spread this out pretty big. So in black are the things that are always going to remain constant in the formula. So then we're going to have a sub 1, and then we're going to add, and then we're going to have parentheses, and then we're going to have the n value, and then we're going to have minus 1, and then we're going to multiply by d. Okay, so those are always going to be there. So we're going to go ahead and label those out. So a sub n is the nth term, or in other words, any term. A term we specifically name. We've mentioned that a sub 1 is the first term. N is going to be, or this whole quantity is 1 less than the number of terms. In the sequence. And it may be just a portion of that sequence, right? Because the sequence can go on forever. And then, of course, we're going to be multiplying that. So I'm going to throw him in just to remind you that is an operation, the common difference, or the pattern, right? Okay, so let's go ahead and we're officially going to go to the next page, and we're going to do 2 examples and call it a day. So let's go ahead and title again. Arithmetic sequence. And then we've got number 1. So we're going to find the 21st term of 11, 8, 5, 2, and so on. Okay, now again, if you sit there and you just keep listing numbers until you get to the 21st term and come up with that answer, that'll give you half a point out of 2. You gotta use the formula. It's the whole point behind this. Okay, so first thing I want to do is see if I can figure out what's going on. What's my pattern? How do I get from 11 to 8? I would have to subtract 3. From 8 to 5, I would have to subtract 3. 5 to 2, I would have to subtract 3. So pretty much that tells me what the pattern is. That's your D value. So I'm just going to write D equals -3. The first number is the A sub 1, so A sub 1. I say it and I write something else. Typical. That's your 11. Okay? Now, what they're asking me to find is the 21st term. So this is the mystery number, is the A sub n number. Okay? And then that tells me that my n is the 21st number. So we're going to kind of pretend that our list of numbers would end at this 21st number. All right, so we start with the formula. We have A sub n equals A sub 1 plus the quantity n minus 1 times D. So we're just going to use A sub 21. Let me get all my equals in here. This and the plus and parentheses and the minus and the 1. Okay, and then A sub 1 is going to be the 11. The n is 21. And we're going to multiply that by -3 now, because the best thing to do is use parentheses. So you understand it's a multiplication problem, not an addition or subtraction problem. Okay, and now we just solve it. 21st term is going to be 11 plus 20 times -3. And that gives me 11 minus 60. And the 21st term is going to be a -49. So that's what I just write. The 21st term is -49. Okay, so let's do a problem where we're missing another piece. So the question could be like, which term of the sequence is 32? Okay, so here's our sequence: -12, -8, -4, 0, and so on. So let's see what we get. Well, based on the information, it says, why did I write percent? Oh my gosh, guys. I know it's past my bedtime, but seriously, that's bad. There we go. So, first and foremost, super easy, right? We know what a sub 1 is. Bink. That's a negative 12. The other thing I know is what is the last number? They tell me a sub n. That's going to be our last number, is 32. Okay? Now, that's not the n number. That's the term we're looking for. So that means I have no idea how many terms are in the sequence, what term that is. Okay, and then let's see if we can figure out the pattern. So let's see. I'm actually getting bigger, so I'm adding 4. I'm adding 4. I'm adding 4. So that's my D is 4. Or plus 4 if you wanted to write that, right? Okay, so let's go ahead and get into my formula. A sub n equals a sub 1 plus the quantity n minus 1 times d. And then I just start substituting in what I have. So let's see, we have 32 equals, then I'm going to get all my constant things in there. The plus, the parentheses, the minus 1. Okay. A sub 1 is negative 12. N is n. D is 4. Alright, so let's see. I'm going to go ahead and distribute. Oops, sorry, let me go to black. And from here, you got different ways to solve this part of it. I can't do n minus 1, so I'm going to distribute the 4. So I get 4n minus 4. I'm going to simplify on the right side, combining up the 12 and the negative 4, and I get 8 plus 4n. I'm going to subtract 8 from both sides, and I'm going to continue over here. And that's going to give me 24 equals 4n. I'm going to use the symmetric property. I'm going to divide by 4, and I get n equals 6. Okay? Oh, I didn't do that right, did I? Oh, yep, something didn't look right. I figured it out. I messed it all the way up here, so I'm just going to go back. I messed it right there. It's supposed to be a negative 12, which makes this guy, oh boy, I did major mess. Yep, definitely bedtime. I'm going to erase all of this. Sorry about that, guys. So I'm going to get 32. Those two add up to negative 16. I'm going to add 16 to both sides. Use the symmetric property. 4n equals 48. Divide by 4. Now this is making sense because, yeah, that would have been too quickly. 6? Nope, we're already at 4 terms. Use logic when something doesn't look right. So we would say 32 is the 12th term in the sequence. Okay, hopefully you won't be doing this late at night, and you'll be able to understand this as you practice it. All right, good luck, guys. We'll talk to you soon. Bye now.